channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your chemistry class, and that is your class 37, which we have to start a discussion about Unit 12, that is your organic chemistry, some basic principles and techniques. So let's go for the same here. For that, here we will discuss about, after discussing the unit, we will be able to understand the reasons for the tetravalence of carbon and shapes of organic molecules. We learn write the structures of organic molecules in various ways, classify the organic compound, name the compounds according to the IPSC system of nomenclature, and also derive their structures from their given names. Then we understand the concept of organic reaction mechanism, explain the influence of electronic displacement on structures and reactivity of organic compounds, recognize the types of organic reaction, learn the technique of the purification of organic compounds. We will able to write the chemical reaction involved in the quantitative analysis of organic compound, and we will learn to understand the principles involved in the quantitative analysis of organic compound. So for that, here organic chemistry, some basic principles and technique. Here in the presence of this unit, you will have to learn that the element carbon has the unique property that is called catenation. Due to it forms covalent bond with other carbon atom. It also forms covalent bond with atoms of other numbers like hydrogen, oxygen, nitrogen, sulfur, phosphorus and halogen. The resulting compounds are studied under the separate branch of chemistry that is called organic chemistry. This unit incorporates some basic principles and techniques of analysis required for understanding the formation and the properties of organic compound. Now we discuss about the general introduction. In terms of general introduction, here the organic compounds are vital for sustaining life on Earth and include complex molecules like genetic information bearing the deoxyribonucleic acid, that is your DNA, and deoxyribonucleic acid, and that protein, the constituent essential compounds of our blood, muscles and skin. Organic chemistry is that chemicals appears in materials like clothing, fuel, polymers, dyes and medicine. They are some of the important areas of application of these compounds. In terms of science of organic chemistry is all about 200 years old. Around the year 1780, the chemists began to distinguish between organic compounds obtained from plants and animals and inorganic compounds prepared for minerals sources, which is Berzelius, a Swedish chemist, proposed that a vital force was responsible for the formation of organic compound. However, this notion was rejected in 1828 when F. Wohler synthesized an organic compound, urea, from an inorganic compound, ammonia cyanide. So here for that, NH4 CNO, in the presence of heat, goes NH2 CO, NH2, this is your ammonium cyanide, this is urea. So here the pioneering synthesis of acetic acid by Kolb's in 1845, and that of methane by your Barthelot 1856, that showed the consecutively that the organic compound could be synthesized for inorganic sources in the laboratory. where the development of electronic theory of covalent bonding that ushered organic chemistry into the modern shape. That is, we discuss about the tetravalence of carbon. Tetravalence of carbon, that is the shapes of organic compound. The first we discuss about it. The shape of carbon compound. So the shapes of carbon compound. Here, the knowledge of fundamental concepts of molecular structure that helps in understanding and predicting the properties of organic compound. You have already learned these theories of valency and molecular structures in the unit 4, and also you already know that the tetravalence of a carbon and the formation of covalent bond by it are explained in the terms of an electronic configuration and the hybridization of s and p orbital. It may be recalled that the formation and the shapes of molecule like methane, which is CH4, ethene C2H4, ethine C2H2, are explained as terms of the use of sp3, sp2 and sp hybrid orbitals by carbon atom in the respective molecule. Now, hybridization that influences the bond length and the bond enthalpy and strength in organic compound. The sp hybrid orbital contains more s characters and hence it is closer to its nucleus and forms shorter and stronger bond than the sp2 hybrid orbital. The sp2 hybrid orbital is intermediate in s character between sp and sp3, and hence the length of the enthalpy of the bond it forms are also intermediate between them. The change in hybridization affect the electronegativity of carbon. The greater the s character of the hybrid orbital, the greater is the electronegativity. Let's write it down. Thus, the carbon atom having sp hybrid orbital with 50% s character and more electronegativity than the possessing sp2 and sp3 hybridized orbital. This relative electronegativity is reflected in several physical and chemical properties of the molecule concerned, about which you can learn in this letter. Now some characteristics features of pi bond. In a pi bond formation, parallel orientation of the two p orbital on adjacent atom is necessary for a proper sideway overlap. Thus, in a CH2 bond CH1, the molecule, all the atom must be in the same plane, and that the p orbital are mutually parallel, and both the p orbitals are perpendicular to the plane of the molecule. Rotation of one CH2 fragment and the respect to the other, and that a maximum overlap with the p orbital, and then there is a such rotation that about the carbon-carbon and double bond is restricted, and that the electron charge cloud of the pi bond is located above the below, and the electron being easily available to the stacking reagent. In general, pi bond provide the most reactive centers in the molecule that containing the multiple bonds. So we go for the question here first. So the question first of the session: how many sigma and pi bonds are present in each of the following molecule? So the first one is so here just sigma C bond C is your 4, sigma C bond H is 6, sigma pi C double bond C 1, and pi C triple bond C is 2. Now for the another one, CH2 double bond C double bond C H CH3. So here sigma carbon carbon bond is 3, sigma carbon hydrogen bond is 6, pi carbon double bond carbon is 2. Now we go for the another one, that is the another important question that we discussed in the next coming class. So here we're gonna end up itself and we'll go for the next question. Second and third we'll discuss in the next question, and the further we discuss of course. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.